look at some Venn diagrams, okay? Venn diagrams. Now remember, these are just the circle things that cross over. So we might have A, B, and C. Okay, we'll call this A, B, and C. I'm going to change colour so it looks a bit different. Alright, so now what we're going to do is put some pieces of information. So let's say set A contains 1, 3, and 5. Ooh, why did that stop working? Ah, my computer froze. Ooh, okay, whoa, there we go, okay. 1, 3, and 5. I hope the sound didn't freeze as well, the computer froze, whatever. Okay, B can contain 2, 3, 6, and 8. And C can contain 2, 3, 7, and 12. Okay, now what we're going to do is we're going to put these in the Venn diagram depending on whether they're in A, B, C, A and B, B and C, or all three. So what is only in A? Well, A has 1 and 5, and they only belong to A and nothing else. What about 3? 3 belongs to A, B, and C, so let's put it in the middle here. Now B has 2 all on its own. It's also got 6. That's also got 8. C has... Oh, sorry. No. I made a mistake, didn't I? B and C share number 2, which means it goes in this little section here, because it's shared between B and C, but not A. And then C has 7 and 12 all to itself. So you can see we can distribute the data in a Venn diagram so we can see how the information is shared. One of the other ways we can talk about Venn diagrams is how to write what is shared. So let's draw another one. Okay, if I asked you to label A intersection B, so there are 2 different ways that we can do things. This means intersection. I'm not going to have enough room to write all this. Oh, it goes over. Good. And this one is union. Okay, so U for union, and the other one's just intersection. So if I want A union B, well, let's call this one A, B, and C. So A intersection B is this bit here. So everything that A and B share. Okay? Let's pick a different colour so that I can start to label everything differently. If I want A union C, this means I want everything that includes everything in A and everything in C. Get my point? Let's now look at, oh, come on, let's change colour. All right, let's now look at, let's say we want everything in C but not B. This little line means not, okay? So we want everything in C but we want nothing from B. So we're going to colour in all parts of C that B doesn't touch. So that would just be this bit in here. Even though some of it intersects with A, that's all right. We haven't specified it can't be A, but it certainly can't be anything that touches B. So let's see, let's pick another colour. Right, we'll pick yellow this time. So this time I want A union B, but not C. So we want everything in both A and B that has nothing to do with C. So we're going to leave all of C out and just colour in those 2 bits. I hope you get the point. Alright, let's do one more. Let's say this time we want A union B union... No, that's not what I meant. A intersection B intersection C. So we want the intersection of all 3 bits. Now that is only this little section in the middle. Ah, I coloured in the wrong bit. I actually meant to colour in this bit here. Because this is the bit, ignore that. Ignore the top bit. That is actually, that bit there, it would be A intersection B, wouldn't it? That was the bit over here that I coloured in the other colour before. Because this bit in the very centre is the bit where all 3 meet. So this is how we talk about Venn diagrams and how we can both write them like this, draw them like this, and then colour in different things.